Can you hear me? I think everyone can hear me.
Yes,
Okay.
I can. Although it was a little hard over the the hold music.
Over the dancing armadillo. Yeah, I know.
Yeah, that's super cool though.
I was a little. I love it too. I think it's VO3 or maybe Sora. I have no idea. It's kind of cool.
Nice.
I love how people are so creative. Cool. I think this is all being live streamed now, so everyone is going to be joining in pretty slowly. Anybody can be let in at any time. I think Maggie, if you are backstage as producer, there might be a way where you can let people in. There you go, perfect. So I don't even have to do it. I love Riverside for this very reason, because it could be streamed and distributed so easily. I've been getting very much into distribution lately, and just like how that works, and like dstack, is this is volume 2 of our community call, and I wanted to bring it back full circle again with the same kind of updates. And again, welcome to anybody who is new to dstack. Everyone, there's a lot of people who have been contributing to Fala's community, the dstack community, the Flashbots community, the Nethermind community, the Near community. And so, I'm just your fellow host, Dylan. And, I think there's like a TEE wave kind of coming. And so I'm very excited about TEEs in general. And so thank you for everybody who is new to the world of, TEEs. So this is a community call for kind of anybody. There are experts on this call, and there can be questions for anybody from anybody. So don't be afraid to ask any question that you want. I want to open it up to just about anybody. So feel free to chime in. You're welcome to join the studio. There's just a simple Riverside link that you're allowed to join in. So yeah, you can post your questions. You can open your mic, I think, at any time, maybe. We could test this out. So we have plenty of demonstrations today just to kick things off. So today we're diving into dstack's latest updates and the new Trust Center release with some of the insights from Marvin Tong and Hong Yin. And so Fala is, the project is effectively using dstack with privacy preserving cloud computing. So for those of you who don't know about Fala, it's like a private cloud compute. So the quick agenda for today, we're also going to be inviting on Andrew Miller. He also has a really wicked MCP demo, and I cannot wait to see it. And then also Josh is going to be joining us later in the hour for the Vibe VM demo using dstack. So it's kind of cool what you could do with ERC8004. So there's some talks about that. Anybody is welcome to talk about 8004 if they want to. We could talk shit about it too. It's cool. I to be completely honest, I feel like trustless agents, and there's like an entire debate on like what is secure with a trustless agent on chain, right? So TEE for the win in a way. And I think like there is really interesting conversations going around about like, blockchain, smart contracts, on-chain, off-chain. What does dstack offer as a way of securing, immutable code? And loved all the conversations. And thank you, Andrew, for having such a cool conversation the other week. We had a black box episode with Flashbots where we talked openly about like the possibility of actually proving code in a way. So I just, the more I learn about dstack personally, the more exciting it gets, the more I learn about it. So hopefully this is a exciting call for anybody who's new to dstack too. So that's the cool in update. So we do have updates about everything about dstack. So Hung did prepare some notes, and I actually have a memorandum of it. So the major feature updates, there's an SDK multi-language support update. We now have synchronized SDKs across Python. I could also just like share my screen. Can somebody else is currently sharing? Oh, so Maggie, I think on the back end, I don't know if I can share my screen directly, so I could just keep talking about this. So I think right now there is a picture-in-picture, right? We have all of these different, that's okay. So let's just see all the different tests. So see how we have this like animation. We can try to switch over the screen, I guess, Maggie in the back. I can't share my screen right now, so we'll just do this for now. Cool. So I'll just keep reading these notes. So yeah, we've now synchronized the SDK across Python, JavaScript, and Rust. The versions are the Python SDK version 0.5.3 are production ready, and that the JavaScript SDK version 0.5.7 is also production ready. And then there is the Rust SDK version 0.1.2 was now just published in crates.io. So there's an XFS file system support. This added XFS as a third file system option alongside ext4 and ZFS. What that means is high IO performance and it's good for databases. And then XFS is great for large files and scalability. And then ZFS, you can think of it for data integrity and compression purposes. So it's effectively file system support added to dstack. So that's ext4, XFS, and ZFS. So that's kind of cool. Developer experience wise, the quality of life and testing and all the reliability. So all the CLI testing suite changed. So it added comprehensive tests to the Fala Cloud repository to verify that the CLI was reliable. So there was a custom domain diagnostic done for a new UI feature. And then the Fala Cloud web dashboard was able to troubleshoot dstack ingress issues. And they were able to do ingress improvements based on that and then configure a max body size for a larger file to upload. So all done so that we could test large file uploads, I suppose. Okay, so next was repository consolidation. We've merged the CLI docs, the SDK, and templates into a single monorepo. You could also find that also in the Fala network / Fala Cloud as another reference that's online. It's able to work for AI coding assistance. So it was tested with Claude and Cursor, and it ran pretty well. It was integrated also with DeepWiki. So it's good for the code exploration of the repository, and then everything that you need about dstacking is now inside of a single place. So there's no more like jumping between, repositories and all that. So the documentation was updated. So that's a clutch. And then new guides are published for ERC 8004 trustless agents. And these will deploy blockchain agents now using the TEE with wallet support. So there's a guide on that was recently released. So just to kind of clarify, I guess, like how dstack is used, it's because of how it's opinionated, there's unique things that enable 8004 kind of compatibility and also usability. And then you could play around with new ideas in that space. And dstack, I guess, is a kind of a gateway to explore TEE wallets. So there's a document also on how the Trust Center, which was also open sourced, and there's going to be a demo about that. I'm going to show everybody on what that kind of search looks like. But this new network attestation is a ability to request and respond to hash. So I have some questions about that. We'll see that later. So there is a domain migration. So for anybody who has any questions, you could just leave them now. I do want to run through all this. I only have one more section. So there's all the all the docs now can be found through directly through dstack, and it's all been committed, which is great. And there's also an exact copy on Phala.com, which is cool too. So we have CVM management all around. There's an improved boot error detection and monitoring tool. There's a better error handler for the CVM when it resizes its own operations, and then enhanced platform stability across the board. So that's the update. And then what's coming next, I guess, like, it's going to be more of like a Vercel like DevX experience overall. The vision is that it's like a zero Docker deployment. Effectively, the way that it's sort of summarized is that it's building a Vercel like deployment experience for confidential computing, which is the ability to deploy from a Git commit, and you don't need Docker images. Not necessarily, you don't need them. It's not required. So the first step to that was this idea of Vibe VM, which is available now. So the cloud IDE can be running and on a real TEE hardware, and it's sort of like virtual on-prem. The code is running in your browser with the VS Code server, and then you have the pre-installed Python, and that could be the latest 3.3 or 13, and then latest like 22 node, and then a browser. So automate the GitHub repo on startup, and then you can get a prompt. So it's pretty interesting how it works. You can, use cursor from your phone in a way. What you build, you can build AI agents with cryptographic guarantees now about where the use of the agent is based on potentially locality. Who knows? Web scrapers, TEE protections, and other sorts of ideas. There's also blockchain agents, and then they have secure key management systems that they might use using T's. So all in one sandbox environment. So you can think of it as a sandbox. And I think this idea of a sandbox is landing home a little bit more easily. So cool. Those are all the updates on our end. Heading into this now, just as a recap. So dstack is a zero trust framework for confidential containers. It powers secure workloads like AI, analytics, using Intel TDX and NVIDIA GPU TEEs. And so this dstack 0.5 update cuts costs and boosts like node yields. So I think Hung, are you on the call? And I think Marvin is just now getting in. Hung, can you hear me? Are you on the call? Let me see.
Hung is not on the call. It's me for now.
Fine.
Yeah, Hung will join soon.
Okay, cool. Right on, guys. So I just went over all the notes and just wanted to open it up really quick if anyone has any questions. Sorry for not sharing. I'm also not the producer. I'm just reading over some notes right now. I can come back to Riverside and try to switch up. But I am not allowed to share my screen, or at least I don't have the ability of sharing my screen. Does anyone else have the ability of sharing their screen? Marvin, are you able to or no?
Not really. Okay. Someone else is currently sharing the screen.
Yeah, I think Maggie is the producer on the back, and I think there is a way I can log in also to the Riverside as the producer, and then try to change this. It might crash my browser if I'm doing both at once. However, we'll try this out.
I guess you can share the screen right now. Hello? Okay. Let's start. Maybe. Dylan, can you hear me? You there? No. Okay.
I hear you fine. Your audio was fine.
Okay. Cool. So let me see. Josh, are you here? Oh.
Yeah, I'm here.
Cool. Do you mind to share? Maybe we could share like the ERC 8.0 for demo based on dstack. Do you think that's something we can do right now?
Oh, right now? Okay, yeah. Sure. Let me.
Okay.
Can you see the screen?
Yeah.
Yeah, so I'll do a short demo. So the way that we'll start off is deploying this. I built a little Vibe VM. So essentially, this is running the AIO sandbox, and I added a login feature. But this allows you to run a code server and also have some additional features that I'll showcase here in a second. But it's really simple to get started. It's not very opinionated. You just hit deploy, and it'll take you to this tab. This is like the Docker Compose file for now. I have some updates to come. But you'll come in here. You'll want to choose a dstack 0.5 version. So we'll pick from. I'll use a dev version. And then you can click CPU-T for now, and click like a large TX instance, and then just kind of add how much storage you need. And then you'll have down here like the authentication enabled or not, and then a username and password. And then you can define whichever repo you want to pull in. It doesn't matter what agent framework you're using. So like even if you have like a separate one that already works for ERC 8004, you can just define that repo here, and it's really easy. And then you just click deploy. Since it takes like 3 or 4 minutes to deploy, I just went ahead and deployed one already. And this is like how I look in the dashboard. I exposed 2 ports. So this port here, 8080, is like will take you to the login. This port 8000 is so I can serve my application while I'm testing. So this is like a perfect scenario for you to just develop an application, have a native TE environment with dstack available to you so that you can, for instance, like generate wallets, generate remote attestations, and build these TE agents. So I'll go here and share this tab. This would be your the login page. I'm pretty sure I put simple password. Cool. And then it'll take you here. And as you can see, it pulled in, it cloned the repo here, the ERC 8004. And we can like take a look at the README here and see like what are the steps to get started. So I'll just see that I need to copy over. I need to change. So I'll change into the directory. I'll copy over the .env example.env. Then I'll look in here. You see I'll have some like things set already for you, but here is like the first part is like the agent domain. we'll want to set this here. So typically, since I'm exposing that port 8000, I'll just take this and add this here and put this at 8,000. And then the rest of it should be pretty good overall. I just have like a temporary thing. And then we also added the like confidential inference so that you can define your model. And then you would just install all your dependencies in this case. So just actually, I'll show the README so that you can see like the steps. Yeah, just -e period. So that'll take a little bit of time to install. It's pretty quick. Awesome. And then just run the application. So do that here, deploy it. Let's see. Cool. So it looks like we're up and running. I can copy and open this up in a new tab. And we have our little dashboard. So this little wallet here, this was generated based off of the agent path string that we defined. So it automatically generates a address for you. It's waiting for some funds. And we're doing this on Ethereum Sepolia because this is using the Ethereum Sepolia contracts deployed by the DAI team to register the agent. So I added like a little button to like connect your wallet. So I'll connect that here so I can fund the agent before we go to the registration steps. Do that here and send some ETH to it. Cool. So that will take a little, like a wait for the transaction to finish, and then once this updates, oh, it updated already. Cool. Now we have enough funds to register the agent. We'll go in here. So we have a funded wallet. We'll register on chain. And if we go back over here to the terminal, we can just kind of see what's going on in the backend so that we can verify things. This should take a little bit of time to register. And once that registers, it'll detect the agent. So yeah, we have agent ID 48 now. It'll retrieve the URL of the agent that we set here. That's one, I think like one optimization I have to make is like make that read faster, because obviously as this registration grows exponentially, this like brute force read is going to take a little while. So now we have the domain. So now we can use the TE registry contract that we created that allows us to verify that the agent's wallet was generated within a TE. So this will, I'll show you like how that looks in the backend whenever that registration process is happening. So I'll verify the TE here. We'll go back. And you can see that when we triggered that, it generated a remote attestation for the off-chain proof. You see the agent public key, the TDX quote, and then I'll do the verification. So we have our TE transaction. That's just like something different. All right, cool. And then I'll come back here. And it should go to the steps of completing the verification after confirming. Cool. So now we're all verified and set up. So that's just like the basic setup for your agent. You can then go into this like developer API to start interacting with the agent. This will like get the information about the agent status, which would show like the wallet address, the ID of the agent, and the two registrations that they have done already. Just have to do some small optimizations. So yeah, you see this pop up here. We can get the wallet, the information here. We can say, hello dstack, sign a message. That's cool. We can get the agent card here and look at that information here. And then you can get an attestation from the application. And then I added this where you can just have the confidential inference be able to generate a script for you, and then calculate the and print out. And you have these like advanced options, so you can include the T attestation or not, and you can define how many retries. So that'll kick off here, and it should end up showing here. I think I put the right API key, so it should succeed. We'll see. Yeah, cool. So the first part is it generated the code here in Python. So like if you wanted to copy the code and run it locally and see and like kind of verify the results, you can. You get the factorial output, and then you get the T attestation data. So you have like the DeepSeek. We use DeepSeek model that we have hosted in GPU-T. And then you can get like the full JSON response like here with all the information that you would want for the verification. Then you can see like the inference, the prompt hash, the response hash here. It's pretty simple. Another kind of cool thing about this is say that you're where is it at? Yeah. If you're developing in this little what's it called? In this Vibe VM, you can also just, test out your application before you deploy to prod. And so like say that you're developing and you have like a new feature that you added, then you can say like, for instance, like this AIO sandbox also has like an MCP. It's pretty cool. You can like look at all the different tools from this MCP. I can like execute shells command. It says hi because it's like kind of dangerous. I can read files. I can list files, write files, search them, run different Python code or JavaScript, and I'm about to like add like the browser search. So then you can generate those and then kind of test it out before you update your agents, and then you can get an attestation of the MCP MCP call because you're say in this like example you're using DeepSeek as well for the confidential inference to generate the MCP tool call. But yeah, that's I don't want to take too much more time, but yeah, that's what I did.
That's awesome. Thank you for sharing. And since you talk about MCP, I know that like Andrew today have a demo to show for Teddy apart MCP. Andrew, do you want to follow up from there, or is the time fit for you?
The question, if you want to ask questions for Josh, you could do those before I go. I'm not on a time rush.
Okay, cool. Dylan.
So I'm I just wanted to cover up really quick, and thank you, Josh, for covering. Just a quick little recap. While I was trying to join in as a producer, the entire thing crashed all of a sudden. So sorry for dropping out. And thanks, Marvin, for picking up on that note. But we were going to ask a couple of questions just indirectly and directly now that everyone is here, which is good. And sorry for the technical confusion. We know how to fix it now. We were trying to switch screens and do all these sorts of things between multiple people. So I'm glad that we got that figured out. So thank you, Maggie. So we were going to do some deep dive into some of the future direction. We're at the 30-minute mark, so there is another 2 demos that we could show, which is Andrew's, and I know you're sticking around, so which is awesome. But we also have the Trust Center. We could go in any order, but the order that we have is going to be the Trust Center is going to be up next, and then we're going to do a live demo of, we already did the Vibe Code VM, so we can move directly into Andrew's demo right afterwards. But first, some QA. So some deep dives. We were just getting on to the fact that dstack basically, as you could see from the Vibe VM, is a zero trust framework for confidential containers, and it provides a zero, sort of like a powerful, secure workload, like an AI, for example, just using this environment, which is the TDX. So that's my takeaway. So, I had a question prepared right ahead of this, and I wanted to understand a little bit better about how dstack is able to verify sort of its attestations, and how do these attestations apply to things like audits or the AI or orchestration or other things. And Hung, I know you're on the call, and I wanted to open the mic to you just to understand a little bit better, like how have remote attestations improved in this latest dstack update? And how do you think they apply now, now that these recent changes have been applied?
Yeah, I'm happy to talk about that. Recently, dstack has the remote attestation using the original, Intel TDX standard format for a long time, and it worked pretty well. And recently, well, not this is not an update in just the last 1 or 2 weeks, but very few people know that besides you figure out, say, the compose hash in RTMR3, replay the event log, and then check everything layer by layer, there's actually a new field we're using in dstack called MR config ID. So in that field, there is a hash of the compose file directly in that field. So in this way, if you want to check the attestation and you just want to focus on what is the program running in this CVM, then you even don't have to check all the event logs, RTMR3 stuff. And this was implemented as a verifier for the red pill stack. So in the red pill stack is a CVM with a GPUT attached, and we bind the remote attestation code of both the CPU and the GPU together. And in that verifier, we have put the compose hash in the MR config. Well, not we put the compose hash because it's already there if you are using dstack 0.5. But in that verifier, I believe that's the first time we have a verifier that just check the MR config ID instead of reading through the event log. And it worked pretty well. So if anyone is interested, you can check the latest doc updates. So I think I can share the doc updates in this chat, and later on we can also put that under the YouTube video description or somewhere so that everyone can check it out. But beyond that, I think attestation itself is pretty good and it's very solid. Anyone can try to use that. And recently, we also made a small update on the attestation verification library. It's called the dcap QVL. And now you can run the dcap QVL in browser because we compile the Rust code into WebAssembly so that you can just reference the WebAssembly to verify everything on browser. So this is also pretty cool to me. Let me share the link of that. Okay. Yeah, I'm going to put it in this chat. And later I will also put that in the YouTube video.
Very cool. There's a question also, Andrew, that you asked. There's a need for formal. Okay, is there a need for formal verification? Or sorry, is there a need for formal methods in dstack?
I kind of just wanted to get you to call on Everett or see if he wanted to introduce himself, because I was pitching dstack to him. He's one of my friends from UAUC and runs formal runtime verification, the formal methods group that mostly do smart contract stuff. And at a minimum, there's smart contracts and the verifiers that might benefit from formal methods. But I hadn't thought about that topic, so I thought it was interesting.
Like, how do they actually perform the verification itself? Like, it's like proving constraints. It's like you could prove a constraint, I guess. Yeah, I guess that makes it easier for people to build circuits, I guess, or maybe it even makes it a little bit more verifiable that something was computed correctly. I guess what in your ideas is the need there? Because I guess like how could a attestation help in this sense?
Well, I thought of two places where formal methods would fit in with dstack. One is for auditing. Actually, I saw this really interesting audit release from Open Zeppelin Security. Now I'm blanking on what was the project, Javo. I don't know anything about their project except that they did a TEE audit from Open Zeppelin Security. That was pretty cool, and they seem to dig into how they use their remote attestation. So I always like to see that. And then formal methods is good as a way of, you know, not just relying on an auditor's human eye to inspect whether some code makes sense, but actually whether, you know, the use of attestation is logically sound. That's kind of what runtime verification excel at for solidity contracts. So that's just one simplifying or systemizing how dstack apps might go about getting security audits could simplify by using formal methods. And then I thought the other is that there's probably something to do where, like, when you load code, like an encrypted Docker file where you don't have the source code for it, maybe you could have proprietary code that you run a formal method on some spec about the code without actually sharing the code, and it gets loaded at runtime. That might be another way that it could be used. I don't know if Everett, you thought of others in the little bit of time we talked.
Quick question on that. Do you think it's even possible, say, we prove that some of the code may be written in Python or Rust, that there's no way for that to share, to leak some user secrets? So, for example, it can be a chatbot or anything, and we can somehow construct a formal verification so that it prove there's no way to just leak the output or input or output in any way.
Yeah,
I
it could be
totally
like
think
a
that sounds
seed.
good.
Yeah, it could be like a seed that like wraps it, and then you just post like an encrypted like base 64, and and it's just a proof, and you can just like say, hey, this is it, and then just like pass the key, and then boom, there you go, there's your code.
Juan,
That's
do you want
interesting.
to?
That's really
I think Juan C, you must be on Everett's team. I think Everett is watching on YouTube and didn't want to approve the permissions that Riverside app asked for.
That's a good point.
But
Yeah,
so the
oh, Juan speaking up. Yeah, go ahead.
Oh yeah, sorry. I was I was pretty interested in a few teams. They're trying to build the audit bot, so they want to send the secure audit bot into some TEE so that it can audit the code, but not sharing the code with anyone else, because the code may be proprietary. So the code owner doesn't want to share. They still want to convince their users their code has some property. So I'm also thinking about for very complex code, which is hard to have a formal verification, but you can still use AI to roughly scan that. Like even for cloud code, it's pretty. Yeah, I personally, if someone tell us you can use this open source code to do something, the first thing I'm going to do is to run cloud code, ask if there's any like anywhere any of the code uploading my information or access my file system in some way, and it can do a very simple code scan for us.
Yeah, maybe we can invite Visual team to the next meeting for dstack code to introduce how they use APIs to detect the security scores from closed source agents, and based on request, not based on one-time configuration. So yeah, I think that's definitely something could work on. Shall we move on to the trust center introduction, because we talk about
I think that's a great
yeah.
transition. Yeah.
Yeah.
Now it's like, yeah, I mean, it makes sense. I get Marvin, you're sharing your screen right now. I also have that pulled up while you were talking about it. But there's also a search as well. And I want to, I guess, like give the a quick overview on, I guess, like what we're talking about background, right? Is the Trust Center, what is a remote attestation? And I think for everyone, this is still live stream. So if you're joining in on the live stream now, we're at the 40-minute mark. We have about 20 minutes left in the meeting. So thank you. Anyone, you could drop your questions over on LinkedIn, over on also in Riverside. You can join at this Riverside link, and it's also posted on the posts. So you could always drop your questions, and then we can always find those, and I'll go find those later. But this is the Trust Center. So it's a way of verifying governance, right? You could be able to access and manage the entirety of your code and how it's structured within your confidential virtual machine. So it's a way of visualizing the remote attestations, which is basically a way of how the system of dstack works. It's 5.3, 3.6. These are all the versions of dstack, but I can look up any version that's currently within the Trusted Center. So these are all applications that have like say like a running dstack mod with it, which could prove things such as the operating system, the key management service, the gateway, and all of these things. And you'll see how the Trust Center kind of works. So I'm going to choose this like private chat. And this just opens up. So this is cool. So this is like the near private chat agent. And I could see, like, I'm the user, right? And I don't know, but this is like a block explorer in my mind, but for apps, but I could trust it. And that's, I guess, the whole point. Like if I'm going to be using the AI internet, I want to verify what I'm using, right? Like maybe apps can't be trusted in the agentic world, which is coming, and AGI is going to be unverifiable. So what better way of being able to verify it with the open source dstack? And I think it's pretty cool. So now we can turn it into like this like cool experience. Purple means attestations. Purple. I remember it by the colors actually. So it's green means the KMS, the blue is the browser, and then the purple is like the hardware. So for anybody who wants to gamify the Trust Center is available. So you could use the code, and it's open source, and so you could design it in other ways. And I'm thinking a dstack hackathon. To make your own Trust Center or present attestations within your own UI in ways that like Red Pill has also done, which is redpill.ai. And that is like a cool way of basically proving to your user that this is a proven gateway, this is a proven operating system, and what kind of operating system, where are its artifacts, and how exactly does this system actually log itself, and like what keys are a part of the actual key management service? Like why is it decentralized, I guess, coming from the some instance on chain, so that you get this CVM to deploy this application source code. It can verify the signature, the SIG store signature, and as well as the actual operating system, like I said before. So you could see that this is running on an Intel processor, that it's up to date with TDX extensions. And so all of that is wrapped up into a nice little report here. And these are your event logs. And then we can even come in here to try to find the RTMRs, where, let's say, like RTMR1, and we can see the app, its code, its its hash, its digest, and all of these things. So we could look at for any specific thing, we can see what it's exactly tied to. So we know it's tied to the app. So if you want to verify the app, I can just verify this exact payload here and know exactly what to send you if you're trying to audit me. So that's why we talked about audits before in the previous session. And now hopefully this makes sense why it's easier for researchers to audit their code, right? Especially confidential code. It's very hard to audit things that are meant to be confidential, but meant to be secure and usable, but not malicious, because they need to be private, but they need to be protected. So I think this is a really great way of auditing a system. So way to go, dstack community. This is awesome rendition of how to prove code.
Yeah, just want to add
Sorry,
up to
yeah, Marvin, you wanna
2
say
cents
something?
from like product team perspective. Actually, you don't have to run. Of course, we build it for now. All of the live applications you can see on Trust Center is using Fala Cloud, but it's actually an implementation component for dstack. So as I'd say a killer feature for dstack. You don't have to use Fala Cloud to get this Trust Center. You can build your own. That's the point. And the major reason why we have that is two group of people. The first group is the security researchers, right? Like because very like high frequent questions we receive from the security auditor or researchers is, okay, you are using TE, so what? How's your OS works, how's your attestation works, how's the internet connection works. So auditors actually need a way to kind of mapping all of the piece of evidence inside a program together to get a report. And I think that's the point of dstack, right? Why we have a key management system and zero trust gateways, so that we can connect the trust assumption into a whole piece. So for security researchers, auditors, security engineers, I think that's a very helpful tool. And B, for retails, normie people, like actually, like after we launched dstack in last year, right? Like many application developers begin to launch stuff or figure out, right? Like if they can using TE can help them to build a new stack or new like innovation ideas, and they most of the times developers who are using TE just add some configuration in the documents and say, hey, we are using TE, and here's the API you can get verifiable, attestation report. But after a couple of months, we talk with many founders on this. After a couple of months, they come back and say, yeah, we do say we have TE and we provide APIs, for retail to verify the attestations, but still, it doesn't actually bring a good virtualization or trust system to the retail, so that they are understanding what kind of level security or how their privacy being protected where they are using these apps or AI. And it's just there's no way for retailers to understand they're using a well-protected security system. So we did some research on let's say Apple Intelligence, WhatsApp, or some even Signals, right, the Web2 products, to understand how they transit the trust relationship and security technology to the general market. And come on, this is not built for retails, by the way. So we get some ideas. So we begin to put the verification badge that people can understand on the left side of each application data. If you can click in any of these applications, you see there's on the left side is basically like human language description for what level of trust you're getting, right? What kind of trust badge you're getting from using. Just click any of the applications. Yeah. Anyone is okay. Yeah. You see on the left side is something like people can actually understand, and on the right side is especially only good for engineers and hard code researchers. So for the next future of dstack, we are also exploring to make the left side, these trust cards, into something like a widget. So if your application is using dstack, you probably get API, and there is an open source maybe front end widget you can easily integrate into your app, no matter it's an AI chat room or an agent or just like a backend. You can plug in the information you need from the TI attestation to your UI, so that your user can feel like better in many ways. We are still exploring on that, so maybe we could share the progress in the next coming calls. Yeah, that's a product guy 2 cents. Yeah,
That's awesome. I love it. It's really cool. And I love how flexible it is and what you can connect to it and where it can go from here and how you can turn it into a widget so that it's easy to kind of like trust and interface with an interface itself. I think that just, yeah, I don't know. It makes it makes more sense, I guess, for some applications too, especially for those that need absolute verifiability over like what they're using. So what do you think is like critical for the AI builders now to use something like this? Like, is there a vision specifically of like who needed to see these types of systems? I know you said researchers, but I know like there's trust badges you mentioned. So I guess like a trust badge in an AI application could mean that you could prove, what AI model you're using, or what MCP cloud, or even just server you're using, or what API you're using, right? So you want to get like a chain of trust going.
Sure. I'll do it very quick. I don't want to waste anybody's time. So, for example, like we upgrade a new version of Red2, and let's see. So, still, it's in very early stage, and I don't want to say like it have make any kind of like success yet. It's not. It's very early, but as you can see, when user is having a chat, AI chat, right, with agent or just an LL model directly, they can see the like 3 pieces of attestation work: the TDS, the GPU, and they basically know, okay, it's protected by the hardware. But after this version of let's say light trust center launch on RIPO, we received some feedback. There's still a lot of questions need to be solved. Like for retails, for example. Okay, how does like TE protected my privacy? Yeah, you show some attestation report here, but how can I use it? And it's still kind of like too cliche, or let's say too technical for the AI users. Some of our clients, a very interesting finding is some of our clients actually working in attorney firms, like they're lawyers, right? And they and we surprisingly found out, even in there's some lawyers in the United States, they haven't utilize AI at all in their workflow because they have higher moral standard. I'm not saying the lawyers who are using AI right now have lower moral standard. I'm not saying that, but there are people like who have a good moral to keep confidential between the conversation with them and their clients because they want to keep those things in secret forever, so they don't share it to OpenAI. And I really find it out, right? Okay, there is private AI. It's kind of like end-to-end encrypted, like how they use Signal or Telegram. They begin to explore something in there. For example, I can upload some files right to agent and just use the rag to begin to search stuff. So yeah, there's something that, but for these lawyers, I would say the verification center is still not good enough, the light version. So we are basically work in our productivity work in two tracks. One is the trust center, the real trust center, which Dina just showed to everyone for dstack, is a whole piece of work, right? It's good enough. We want to make it good enough for security research labs, for security experts to buy in the security assumption based on dstack. But in another hand, we also need to always abstracting the information from the whole piece to some piece of security card like what you see on the right side to make the retails understand what they're being protected. I would say there's still a big gap from it. We're working to shrink the gap, but any feedback from you guys from the community will definitely helpful to this.
Yeah, thank you, Marvin, so much. And we still have a little bit extra time right before. And Andrew, thank you. We are blasting through this. And so, Andrew, I would love to bring you up now also to share if you have if you want to share your screen.
Yep.
We can show off the next demo, which is, I think, how you've been polishing and how you're taking this, and would love to hear your thoughts on how everyone is sort of taking various ideas in AI, and so you're modifying the MCP tools themselves. So my question would be, what is a self-modifying tool? Is there any kind of paper? I've read only a few papers on the self-modification or the agentic flow of how tools sort of build themselves. Is that what we're talking about here?
Not really. I think I'll try to explain this, and I think it'll be kind of clear. So this is an MCP tool that is useful to establish an anchor of trust between multiple different agents that are presumably run by different people. And this is meant to be an MCP tool that's like a neutral playing ground that creates common knowledge between them. And the interface is kind of cool, so I think you'll get it from a demo. So this is an MCP tool, so it's a server. It's running in dstack, have a recognizable dstack URL in there. It's called Teleport MCP. It has a bunch of tools for creating a channel, joining a channel. And when you create a channel, you also get to provide some inline code. That inline code becomes the thing that runs in this common knowledge environment. So I will start by making I kind of blasted this. I wanted to have something copied. Here, we'll do it this way. So you tell it you want to create a channel, and you tell it what you want it to do. I'll just change it to Solana price, and then it's going to join. This should probably be skipped. It's going to join the channel, give you an invite code that you can pass to someone else and their agent, and you'll both get to use the Solana price oracle. So this is kind of an instance of vibe coding or self-modifying MCP tools, because the bot is going to one-shot some inline code that runs like this. The on init, on join, those are defined in the MCP tool itself. They're part of the instructions for the agent on how to use this MPC tool. So it basically creates a channel with 2 invite codes and one instance of a script running the code that it just wrote that does some kind of price oracle. Because this is broken out into 2 steps, Quad has to go use a separate MCP pool to join with its own invite code. another MCP tool call to list everything in the channel. And now it's going ahead to syncing is glitchy, but it works eventually. It basically asks the thing to do this. Now, to demonstrate this in the fun way, the point is to use this between AI sessions. So I can take this other invite code and say, join this channel and tell me about the code in the channel. I mean, and obviously an ordinary, it only knows that this makes any sense because it's got the MCP context that tells it language, like, oh, this is a thing for joining channels that takes an invite code. Anyway, so it joins the channel. It can tell that there's a custom bot, so it has to go read the code. And now it understands what the code is. You got, the human can inspect this code and, do it as well. I think I had to encourage it to try it out by posting a message. And that's it, you get the idea. So it's mainly illustrating two things. One is using an MCP as a bridge between two agents. The agents don't have to trust each other. So I think that this is a bit of a, my constructive critique against the 8004 thing. This isn't about trustless agents, but about trustless infrastructure that distrusting agents can use between them. So yeah, that's all. This is meant to just be a little suggestive research proof of concept as well.
That's really cool. I that just clicked as soon as you put it in, and then it was able to connect to the same, but it's a private, right? It's its own server, and you're just hosting it, and it's its own inference effectively. I think that's super cool. Have you scaled this to like how many times you could scale this? How many clouds you can? How many windows can you open up? I don't know how many windows you can make that connect to at once.
I will say that the funniest thing is that the first way that I did this, the whole thing obviously vibe coded. So the real session that was fun was leaving it open without let's see where's going to be the one that's good. The first version didn't have any sandboxing. So the fun thing you could do is like create a bot that lists everything about the current execution environment and try to get root on the execution environment. And so I actually walked it all the way through, rooting itself, and then use that as a basis to fix the sandboxing thing in it. So you can do some surprises that, switch between these. I think for this to be meaningful, it would have to be like multiple MCP servers would have to federate. This works because I have multiple quad sessions, but they're all connected to a single instance of the MCP server. So, that would probably also need to be managed.
So they could effectively use trusted endpoints, and then they can govern themselves through these trusted channels to communicate. They know that they can trust X, Y, and Z, I guess, like links to these chats or these ports, and they would be able to have like a sync, sort of in sync, in parallel chat with one another. So you can have an agent that speaks to this agent, and they know that they're speaking to the same agent. That's interesting. So now it's almost like as if the AI is the API. So makes MCP make sense, like by a lot. Wow. And so this is, what model is this running? Is there any
just on it? I mean, the MCP tool doesn't have any element. There isn't any secure inference. It just runs code. So the MCP, tool is basically just a thing that lets you create a channel. It just a very simple API that lets you create channel, join with an invite code, and carry out executions. It uses the Claude OAuth stuff. So I mean, actually, I guess it is only allowing connections from the Claude servers. That's just how Claude does its MCP, calls. So yeah, there's something like that, but I don't think that this is really relying. The agents here are trustless or not trusted at all. They're regarded as untrusted. The MCP tool itself is the only thing that carries the attestation, and it itself doesn't do any inference. It just runs some code in a sandbox.
And
Josh, you
how
had a
does
question,
the
but
Oh yeah, I got a quite quick question. So, how does the unthropic authenticate with the MCP? Is that the OAuth, Andrew, you have mentioned?
Yeah, it's kind of a mess, but I had to go figure it out. It just has anytime you make an MCP tool that you can just add to Claude, you have to go through these things. And it took a little bit of grinding to figure this out. And it seems fairly like different for every, this should work with OpenAI, ChatGPT connectors as well, but I didn't get it to work because it seems to have an incompatible OAuth thing. So I think that this is just stuff that everyone trying to make an MCP tool and connect their Claude to it has to go through. But nothing otherwise too special about it.
Mhm. I can imagine this is very interesting in a sense that we can imagine like a cloud as a operating system, and we can plug multiple players from their cloud into, like, say, a system, and they can cooperate. um, I don't have the idea of what we can build, but I think there are a lot of things we can explore in this in this design pattern. That's super interesting.
Yeah, totally. I mean, and in light of these previous presentations too, it's interesting to think of that trust center thing as essentially being infrastructure for agents to evaluate, because now my agent has to make a decision whether to proceed based on trusting stuff that came out of this tool.
Mhm.
Yeah.
MCP for Trust Center. Good idea.
yeah, you get to see what's going on within the MCP that doesn't make any sense because it might have so many tools. I've been hearing a lot of the rumors about how MC just servers are just going to be so overly complicated and they're going to have all of these various auths and verifications that don't make any sense and how to maintain it. Maybe it's going to be useful to use dstack in this sense so that it can make the MCP service more manageable in a sense. That's the first thing that comes to my mind is that I would like to audit the server based on its tool and its usage. I want to verify each of the tools. That's really cool. And then Josh, you had a question. I'll just say it here, but I think this is directed towards Andrew, which is there a potential connection between Claude and GPT through the same channel?
Oh, yeah, definitely. I mean, it's totally neutral regarding just they both have weird different OpenAI things, and I couldn't get them to, or OAuth things, and I couldn't get those resolved. If you know how to attach an MCP, make your own MCP server and have ChatGPT use it, I'd love to know.
Is that not what A to A would do? I feel like that's why A to A maybe could resolve. Maybe this with just like JWT between them. So could they also connect in the chat with just like posting their own tokens to auth with one another as well, I guess?
Yeah, probably. PR's welcome.
Cool ideas. I love this. All right, cool. Awesome. And we have closing questions, and I'm going to be looking for any of the questions that are actually across. We have a YouTube streaming this now, and then there's also on LinkedIn and everywhere else. So we can post the questions here in Riverside if we do find them. I'm going to be looking around, but if anyone has any questions here, there's a couple of people who are.
Yeah, I think Juan got a question. Maybe we could cover that in the Riverside channel.
Yes.
Yeah.
Let me check it here. We have so yeah, formal verification can absolutely be integrated. For instance, CI automatically revalidating any proofs that were passing before. So this goes all the way back to formal verification. So there's been an open discussion here about formal verification, and hopefully maybe we can answer any questions now. So you're free to unmute your mic if you want to ask a question now. And yeah, this is open conversation time, and any updates on anyone end on dstack. I think we've gotten through all of the demos. We did Trust Center, and thank you for everyone who attended so far. But now we're open to open QA on logistics. And one of the first questions that we did have is Trust Center live like right now? Is it able to be integrated, or I guess like is it still pending? Hung, I don't know. Anyone who wants to answer this, it's is this live right now for developers to integrate?
Oh, sorry. I was yeah, could you repeat the question?
Oh yeah, is the Trust Center available now to integrate for developers?
I think we may still need 1 or 2 weeks to make it fully ready, but whenever you have any demand, let's get connected. We can of course enable the preview version for anyone who are interested. And ideally, I would like to make it like a self-serving portal. So if you deploy using dstack on Fala Cloud, there's one button, you just click that and you get everything ready. And on the other side, if say you just have some self-deployed dstack, we can also give a API so you can upload your proofs to that API and we can get the page for you. It's not as complete as that at that point, at this point, but I think maybe in 1 or 2 weeks, we will be there.
Actually, Trust Center is open source repo right now. But directly using Trust, you can try it, and I'm welcome to give any feedback. If you made any progress while modifying it, yeah, cool.
So I looked over Twitter. It looks like we don't have any questions on Twitter yet. So cool.
I guess
Everett, you should just jump in and say hi.
Hi. Yeah. I guess I was just wondering earlier talking about like auditors using this perhaps, and just kind of what demand you guys have seen for that, or what indicator, because we work in the audit business, so I'm just wondering, how have you talked to anyone who was like, yeah, this would be helpful for us in the audit business or anything like that?
Yeah, I think like for example, like one of our client, right, their client is financially, so like each of their client actually have some pretty good security engineer in their own team. So where they're trying to integrate their application into a new system, they need to kind of understand the trust assumption behind everything. Otherwise, they will just ask for on-prem deployment. That's the most security way for this enterprise. So in that case, because our client, they are providing a platform and they don't want to do on-prem deployment, so they use confidential compute, right? And to sell their product, they got to onboard these security engineers aligned with, okay, this is kind of safer than using AWS. This is almost equally secured as on-prem deployment. So that's how Trust Center works, to help their in-house security engineers to work. And in another case, while we are auditing the dstack code, we talk with ZK. I think the team is ZK Verify, right? Is that a audit firm, right? ZK Verify.
ZK Security.
Oh, sorry, my bad. ZK Security. And while Wang is auditing with dstack code, we also showed up this kind of stuff to help them put the relevant pieces together. But for serious audits, right, they need to read the code and audit step by step. But this kind of trust center mapping help them to connect the evidence together to understand the architecture.
Yeah, thanks. I guess, yeah, you linked me to a security audit. I was just wondering for a firm like ours, what the use case would be. But I understand the enterprise use case there. And I guess I could also think of a situation where if we had a very, very paranoid client that wanted to, control every access we had to their code or something like that, or make sure that we only accessed parts of it at a time, or they could see exactly how we access different parts of it and what sort of tools we used on it, maybe it would make sense. But that hasn't been my experience. My experience is usually that we have to convince smart contract developers to be more paranoid than the other direction around. But
Got it.
yeah, curious to learn more, and I'm also very newbie at this. So
great question, actually. Like, I would say like off-chain security audit is just there's too much complexity and parameters in there, right, to affect the trust assumption. So you need to audit not just the code, but also the libraries, the OS, the hardwares, the gateway for internet connections. You need to audit too much component, and so I'm not saying like using dstack or TEE plus with Trust Center, right, can help matching the security requirement, but we just need to build something to speed up the acceleration process. So I think that's a goal of this product. Cool.
Yeah, and also just so that we all have future reference for the next meeting, all of the comments from all the places where this dstack community call is being hosted, anyone can go to the chat that they're on YouTube, they could be on X, and just post there, and it actually enters into this chat. And if you want to join this chat using the direct Riverside link through the Luma page next time, you can always come back to the Luma, freely register. This is no expense. And you can bring your best questions. You can bring demos if you would like to for the next call. Now, we are a little bit over time. If anyone here has any questions, or if anyone here has any last thoughts, make your voice be heard now or forever rest. And but thank you for everyone who did attend today's call. I think learned a lot. I definitely that blew my mind with the whole MCP Vibe VM and watching everything happening and seeing how dstack is a part of all of this is actually kind of crazy. So wouldn't it be insane that we had a community of AI developers using this as well? I think it's totally possible to see this community grow, and for us to have like a really cool stack that everyone can know is democratized, is is audited, is secure by design. And you could see hopefully by today's end of the call, if you stood for the entire thing. Thank you for watching. We had over 500 people join, so very, very happy about that. And so thank you for all of your time. To all the people who are completely new to dstack, I want you to come next time and just go to the dstack GitHub and you can read all about it. It's got a lot of lore. Where it started, what it uses. It uses Intel TDX and various other environments as well. It's compatible with quite literally anything. It's open source, and so here you're seeing demonstrations be tested now using TDX. And of course, there are others who are testing it in a variety of ways, and many foundations come together to use dstack for confidential compute. And so it was recently added to the Linux Foundation with a good 17 out of 17 vote. So that's just some really recent news for anyone who doesn't know that. And it was audited with pretty solid results from ZK Security. So go check those out. They're online everywhere. And yeah, and definitely make sure to star it just so that you could, fork it. So you could, use some vibe code VM, use Claude agent on dstack to test it for yourself to see what it does and what it's all about. Or you could just use the deep wiki now that we've updated all the documentation in the last couple of weeks. So everything is fresh and updated. So have fun and definitely bring your ideas to this meeting. You could always register through the Luma link and demonstrate your own dstack projects as well. So it's open to the community. So yeah, thank you, everybody. Does anyone have any questions before we end the call today? No, guys? Awesome. Well, thank you. Awesome. We'll see you in the next 2 weeks. This happens bi-weekly as well. So we'll see you at the start of the end of the next week in November. And then there is DevCon, and then there's going to be other events and other things happening around the world. So hopefully we catch you right before you go to DevCon. and maybe you can think about deploying your next project before you go there. And Buenos Aires, and there's other really wild events. There's also Open Source Week. So some of us are in town now for Open Source Week. There is a dstack Web3 cross-bleed event here in San Francisco tomorrow. So if anyone is in San Francisco, you can come and meet the dstack people and some of the community and see what everyone's deploying. And there's going to be a lot of decentralized storage people coming for some reason. So I'm interested in knowing why. Confidential storage, maybe. I don't know. Sure.
Cool.
Okay, guys, thank you so much. Hope everyone has a good rest of your day.
Thank you for spending your time. Yeah.
Thank you.
Bye.